topic we're going to be analyzing with this experiment is friction. Friction is the resistance to motion of one object moving relative to another, or on a certain surface. The coefficient we're analyzing is the static friction. That is a number usually between 0.01 and 1, depending on the characteristics of the surface. When this number is very high, the friction is actually greater. And in the case the number is small, there is a little friction.
Procedure. 1. Place the plane at the ground level and have the extreme A hinged. Make sure that the extreme A remains fixed. The only extreme that can rotate is extreme B. Step 2. Attach the assigned surface to the base of the container. You can stick it with glue. Here we use this clothing to simulate another surface in our. Step 3. Place the first mass inside the container and put the container at the center of extreme.
This is a 0.2 mass.
Step number 4. Very slowly raise the level of the extreme B so that plane passes through the different angles.
And now we're going to measure the angle. This is for the first mass, that is 0.2 kilograms. And we measure the critical angle.
Repeat 9 times.
Now we're using a mass of 0.4 kilograms. We're using a mass of 0.6 kilograms.
Now we will calculate the average critical angle of this.
The first thing we will do is to write all the data in some papers. After we write the 10 angles or critical angles of each mass, we will calculate the average mass or average critical angle of each mass. How do we do this? First, we will make a sum of all the critical angles of each mass, and each sum will be divided by 10 because is the number of angles that we got. And the result will be the average critical angle. So you will try to do this for each mass that was in our wood and container. So, the last step of our experiment to confirm that the mass does not affect the coefficient of static friction is to get the coefficient of static friction of each mass. How are we gonna do this? First, we will have to have the 3 different results, and what we are going to do is that in our calculators we will choose this bottom that it's called tan, T-A-N, and here inside the parentheses we will write or put the number that is the result or final average critical angle, and we will do that with each mass. So, as results, we will not have the same number because it was not the same average critical angle, but our results have to be similar. For example, 2.61, 2.70, and 2.68. So as we can see, the mass does not affect this coefficient because it has nothing to do with the friction between the two surfaces touching each other.
So, in conclusion, it is important to know and recognize this term to analyze object, either in movement or in balance. The movement also depends on the angle of inclination of a certain surface, which in this case our surface was a table, with their respective measures covered with cloths so that the friction is greater. Because the friction is greater, for the object to slide it needs a larger angle.